Now let's take a look at measuring humidity with an Arduino. It's actually fairly simple. I'm going to be using the DHT11 sensor. It's one of the most common humidity sensors out there. It'll cost you a few dollars, under $5 for one. And what's nice about this one is it will measure between 20 and 80% relative humidity, plus or minus about 5%. It'll also measure temperature between 0 and 50 degrees C, plus or minus about 2 degrees Celsius. It's very easy to hook up, and there are quite a few different models out there of the DHT sensors. The difference between the models is how much humidity or what the range of humidity would be, same with the temperature. There's also a difference in some of the more sensitive ones that measure higher humidities or lower humidities that you can only pull for data once every 2 seconds or so. This one you can pull every second. It relies on a library, just like many other Arduino sensors, making it very easy to use and hook up. So let's get started. First, I want to draw a quick diagram so we can see how to hook it up. So looking at the front of this sensor, and I'll draw it a little bigger here, kind of looks like this. And it has this plastic cage around it, and the reason for that is it allows humid air or ambient air to circulate through to the sensor. And there are 4 pins coming out of it. This is pin 1, and this is connected to positive 5 volts. This is pin 2, and this is connected to digital pin 2. It's also connected to a pull-up resistor. The one I bought happens to come with a little 10K resistor here. There it is. And being a pull-up resistor, we know that pin 2 should also connect to, through the resistor, positive 5 volts. Pull-up would be pulled too high, pull down would be pulled too low or ground. Pin 3 is actually an NC, no connect. And pin 4, probably guessed already, to ground. That's it. 3 wires, a library, we're good to go. So let's hook it up. I will pick rows 1 through 4 on my breadboard here. And we know that pin 1 will be connected to, and let me unplug this first, 5 volt. Simple. Let's connect the ground. That's pin 4. Connect it right over to ground. And pin 2. Fairly easy. Goes to pin 2, goes to digital pin 2. And we have to pull it high. Now I could run it from pin 2 to the positive rail and then over to the Arduino. I could run it to another 5 volt power supply, but you know what? With a breadboard, we can just connect rows 1 and 2 here of the sensor, or pin 1 and 2, together. And that will automatically bring pin 2 to pin 1, which is connected to positive 5 volt through the 10K resistor. That's it. That's all you need to do. Now, I happen to know one thing. The library in Arduino right now was not updated, so we're going to go ahead and do the manual installation for this library. So we'll go to Adafruit, where I bought the sensor. Do a quick search for DHT. There it is, the DHT11. And I go down here to the tutorial. Click on single page. I can scroll down and there should be a nice button for downloading the library. Here it is. Arduino library and example code. And it's a GitHub. And I click clone or download. Download the zip. I'll show that in my Finder. On a PC, it's just your download folder, no big deal. Put it on my desktop. Open up the zip. Now here's something interesting. There are hyphens in between each one of these words. I tend to get rid of those when installing these folders. You cannot have spaces in here. So you can just delete the dashes in there. And then on a Mac, you would go to your Documents folder, Arduino, libraries and just throw it into that folder. I'm replacing it because I've had it installed already. I used this on a project a while ago. Now when I load up my Arduino, if you have it running, make sure you quit after you install a library, then open it up again. We should be able to go right into File Examples, and here it is, first one, DHT Unified Sensor. I can plug my Arduino in now. Go to Tools, Proper Board, and the port, not in yet. It'll get there. There it is. Perfect. Arduino Uno. And before we upload the code, let's walk through it because this code is written for several different versions of the DHT sensor, and there's a few things we need to do. So again, the beginning here has a link to the GitHub code and everything you need. These are the libraries that it relies on. Again, we're not going to go over the libraries because we don't care. We just want humidity. We want an input so that we can react to it with an output. Defining what pin the DHT is connected to, which is 2. I've already connected that. And then here you go. This is what we need to do. Uncomment the type of sensor you have. So when it's commented, it doesn't use it. So I want to uncomment the DHT11 and comment out the 22 and the 21. So these now are gray and they're commented so they will not be used. And basically if we look through the code, I'm not going to walk through it step by step because honestly it is so easy. The serial begin, we have serial communications. We print out the temperature, its unique identification number, its minimum and maximum values, and then in the loop, we basically delay a specific amount. The DHT11 you can pull every second. Some of the other ones you have to wait 2 seconds. This one we can pull every second, and we are literally just going to print the temperature in degrees Celsius, the humidity in degrees Celsius. If there isn't an event happening, it will also print an error message. So let's see what happens. Let's upload it. It's uploading. My little yellow communication dots are blinking like crazy. That's good. It's done uploading. I can open up the serial monitor. I'm getting a reading here of 25 degrees Celsius and a humidity of 50%. So my multimeter actually happens to have the same features. So let's take a quick look at what my multimeter says the temperature is. 25 degrees C, same reading. I'm getting 44% relative humidity. Now I'm reading on my DHT11 49, here's 44. I like to let these sit for a little while before we get a very precise reading. Let's do a quick test. If I blow on this, the degrees C should change and the humidity. So let's see if I can get both of those to go up. We'll go over here and take a look. And you can see the humidity went up to 56, temperature's up 27. So it's working perfectly. That's how easy it is to have temperature and humidity sensing with an Arduino.